Before we get started, a quick note. If you haven't yet, please listen to episodes 2 through 4 in this season on Learning to Change, where we tell the stories of 3 groups who've modeled our season theme. We had to cut so much good stuff out to create those stories, so now we're releasing extended cuts of the individual interviews. We hope you'll like them as much as we do, and that they lead you to a richer appreciation for what it means to learn to change.
This is Climate Conversations by ClimateX.
In this episode, we're going to be playing an expanded version of the interview we did with Ari Epstein, a senior lecturer at the MIT Terrascope program. We had a great conversation with him and wanted to share more of Ari's thoughts than we were able to include in the previous Terrascope episode.
I'm fascinated by the Terrascope way of doing things. And today we have the perfect person to tell us about that Terrascope way, Ari Epstein. He's a lecturer in Terrascope, and he's been with it from the first year of its operation. Welcome to Ari.
Thanks so much for having me.
So Ari, please tell us a little bit about the goals of Terrascope. What makes it unique?
A whole lot of things make it unique. So Terrascope is a learning community for first-year students at MIT. It's one of 4 learning communities at the Institute, and it's entirely voluntary to join. Somewhere around a fifth of MIT first years join one learning community or another.
A learning community. So this is something aside from or different from the conventional MIT experience.
You could argue that all of MIT is a learning community. So how is this a special learning community?
So within the learning communities, we differ in a variety of ways. You all have different flavors, but the things that are common among us, we have both social and academic sides. We are relatively smaller communities within which first-year students start to create friendships and build connections throughout the Institute in a sort of a much smaller community-based way. And we each have a certain focus that we stick to. So I'll just describe it for Terrascope. The social aspect of Terrascope, we have a common space on campus that's available to the students 24 hours a day. There's a lounge, there's a kitchen, there's a study space, and they're using it really almost 24 hours a day, sometimes 24 hours a day. And you can find Terrascope students, not just first years, but upperclassmen who've taken Terrascope in there pretty much all the time, doing something together or working on their own. So there's that social space. We also give them lunch once a week, sometimes with a speaker, sometimes just as a community. We go on community outings. Every Terrascope student, almost every Terrascope student, is advised by some faculty or staff member who's affiliated with Terrascope in advising groups. So there's that community feeling. The academic side, we have a number of classes and a field trip. And I think the thing that sort of characterizes, there's sort of 2 things that characterize all of our classes. One of them is that they are heavily student-driven, project-based, team-oriented learning in all cases. And the other is that they all have something to do with sustainability and the environment.
So is there an overarching theme every year that you guys pick? So
Right.
like, for example, you did Cambridge and Bangladesh last year.
Right. So every year we pick a theme that is sort of the theme problem or issue for the year. Mm-hmm. And each of the 3 classes in one way or another deals with that theme. So the fall class is called Solving Complex Problems. And we give the students a huge, difficult problem to solve. That is the core of the year's theme.
Could you describe the theme of the class this year?
Right. So this year's theme, the problem that we gave the students was sort of a twofold problem. Part of it was come up with plans for adapting to the effects of climate change on the MIT campus and in Cambridge, the Cambridge area in general. And then the other part of the question was come up with plans for adapting to climate change in coastal Bangladesh. And the idea there is you have 2 really different places with really different social, political structures, also very different sort of scientific issues, very technical issues. And the hope is that in coming up with plans for those 2 places, the students can start to sort of triangulate from those 2 to other places in the world. So they had a semester, first-year students coming into MIT, there were about 35 of them, and they had a semester collectively to come up with those plans together. And at the end of the semester, they presented their plans in a website, a public-facing website in technical detail. And then we brought in panelists from anywhere in the world who had expertise on these issues and the students had to present and defend their plan in front of the experts.
So we had one of your Terrascope students, Lauren, come up in our studio just a few days ago talking about these experiences.
From a different year, but it seems like there's a Terrascope way, perhaps. I'd love to have you reflect on that, of you put these students before a big problem and just kind of cut them loose. And they wrestle deeply with what it means to take these problems on. Take us through a little bit of that experience, how you're approaching it.
Right. So the idea of all of the Terrascope classes is that they are heavily driven by the students, and the students are really in charge in a fundamental way. It doesn't mean that we sort of just leave them alone, but it does mean that they have an enormous amount of autonomy. So if they want, they can rewrite the problem, and they have in the past. They can reshape the problem. They can tell us we got it wrong. They can choose what piece of it to attack. They can choose how to go at it. They can choose how to divide themselves up into teams in order to attack the problem. All of these things are open to them. We give them an enormous amount of support. So they're the instructors, there's a graduate TA, there are undergraduate teaching fellows who've been through this experience before. There's a staff of librarians who are attached to the class who do wonderful work for us. There are some alumni mentors who also help. So there's a lot of support for the students. And over the course of the semester, we provide nudges. We sort of provide a little bit of a nudge here or there to try and sort of help the students find.
So what does a nudge look like?
So it can look like a number of things. So on an individual level, we have the students write journals every week to us. They're very short, they're very informal, and we respond to each journal every week. So if we feel that something's going on in one of the groups, some sort of conflict, we can, if we choose, ask the students. So for example, if there's a team and 4 members of the team say, well, everything is going, really great, except there's this one person who's not holding up his end of the bargain. And then the 5th member of the team goes, everything's going really great. Well, we know what's going on in that team, right? And so we can start talking. Or if everybody in the team says everything's going great, except for one person who says, nobody ever listens to me. So in a case like that, we can then write in our comments to the other members of the team, what are you all doing to ensure that everybody gets heard? What are you doing to make sure that your team is fully inclusive? And simply asking that question can make a huge difference. On a larger scale, from the point of view of the class, we can a variety of things. So for example, if they're having a little bit of trouble trying to figure out how they want to run class, because class times we have a couple of lectures, but mostly they're running class themselves. And so there's a question, do you want to have a leader? Do you want to have a moderator? Do you want to just have a free-for-all? So suppose one year they're struggling with how do you actually moderate a class? Well, one of us might get up and model that. And we might not tell them that we're modeling that. We might tell them, but we're getting up, we moderate the class. This is what a moderator does, and making sure that everybody's heard and not injecting our own opinions and so on. And so that gives them a model that they can then carry forward. Or we might at the beginning of a class say, for every class, we're going to give you 2 interesting facts at the beginning of class. But if you choose those facts really carefully, you can help the students adjust their focus. You can help them help them think about things they hadn't thought about before. But fundamentally, the struggle is theirs. So I just want to say this is really unusual for a first-year student at MIT.
And I was just thinking, you're a first-year student at MIT.
Yeah.
It's pretty overwhelming to start with, I think, for a lot of them. And now you're saying, here's a very complex problem. You guys need to figure out how to do it. How do you engage with the emotional and intellectual challenges of just that complexity? There's
a lot there. One thing that really helps is that this is the setting in which the students really have autonomy and ownership. MIT is a wonderful place. The first year at MIT often involves a lot of sort of laying down the basic foundation. So, taking the first year of calculus, taking the first year of physics, taking some chemistry, taking biology. And those are necessary for what the students are going to do, but they're doing the same problem set as the other 200 people in the class. And they're doing a problem set where somebody knows the answer to all the problems. And so in Terrascope, they actually have ownership, and there's a certain kind of freedom that comes with being in charge. I mean, it's, as you say, it can be overwhelming, but it also can be freeing because you can get to decide. The other thing that happens is it's a big team project. If they're anywhere between 35 and 80 people in the class at one time or another, If I'm overwhelmed one week and I just can't contribute anything, I can tell my teammates, you know what, this week I'm just going to disappear from Terrascope. I'll show up in class, but I'm not going to do any work, right? So you guys have to carry the burden of the team for a while. And then maybe the next week I'll pick up the burden and you'll drop it for a little while because you're overwhelmed in your classes. So the communal aspect of it, the fact that we're doing this as a community and that you put in as much or as little effort as you want, I think moderates that somewhat. And along with that, what moderates it is the fact that this is the class where you get to do something you really want to do and something that is your own thing that no one else in the world has ever done.
That sounds really powerful.
Yeah.
And I'm wondering, how did you learn how to do this style of education? And how did you convince the institution, which has lots of more structured ways to get people through their freshman year, to take this on?
Okay, so all we've been talking about so far is the first semester class. So for this one class, the history of the class is that it was actually started by someone named Kip Hodges, who at that time was at MIT in the Earth, Atmospheric and Planetary Sciences department. And so that approach, I mean, we've moderated it an enormous amount over the years, and we've sort of fixed it and played with it and so on. But that fundamental idea is really started with Kip. And he started teaching it in the fall of 2000, and he taught that class twice in itself. So that time it was called Mission, so Mission 2004, Mission 2005, because that's the year the students are expected to graduate or in the class. And then the third year was the first year of Terrascope. So that particular class has its origins there. But I can talk a little more generally about sort of how you teach in this way and how you learn to teach in this way.
I think so.
Right? Because I've taught lecture classes. I've taught I've taught other kinds of project classes. It has to be something that you are tuned to and that you really want to do. For me, and I think for folks who really enjoy doing it, it's much more time consuming and difficult than a lecture class, right? A lecture class, you can prepare your lecture, you can deliver your lecture. In this, you need to be aware of what's going on with the students all the time. When you're in the classroom, you need to be able to react. You don't react that often because you don't want to push them around, but you need to be on your toes the whole time and ready to react in directions that you're not prepared for. So it really requires spending a lot of time being heavily aware of what's going on with the students, what's going on with their process, thinking in a certain amount of detail about where you think they're headed and whether you think they're headed up into any roadblocks that are going to be really too painful for them, or whether they're headed into roadblocks that will be just painful enough.
Yeah, we heard about some of those from Lauren, that like, oh, you guys forgot about cost. But
right.
you point that out after they've worked on it for a while. Yeah,
right.
That's good pain, right?
It's interesting. Years ago, there was a conference on project-based learning, and it happened to be at MIT. So it was easy for me to present along with a student, right? We didn't have to provide airfare. We just walk across the campus. And so what we did was I set it up. So we have undergraduate teaching fellows who've taken the class and are now upperclassmen. And for that conference, I gave a very short section of a talk on sort of the structure of Terrascope. And then I introduced this student. Her name's Erika Erickson, really a wonderful student. And she got up and talked about her experience being in Terrascope as a student and her experience as a teaching fellow. And the thing that she really stressed was the value of frustration, right? And that's a tricky thing, right? Because we love our students. We really, really like them. We really want them to be happy. And we recognize they have a lot going on. And yet, some of the deepest learning comes from a place where you are frustrated and then you dig your way back out of that frustration to an actual answer. And so figuring out how not to take away that gift to the students, right? Right. If you say, here, do it this way, here, do it that way, you're not doing them any favors, right? And one of the things that's interesting about the class is the Terrascope classes in general. It does happen every year that there are some students who at the end of this semester are frustrated in one way or another about the class, or sort of feel a little left hanging by the frustration of the class. And then a couple years later, 3 years later, 4 years later, those students will come back and say, wow, that was the most important experience I ever had. Because you don't truly recognize the value of the experience until you're off on your next team project or the team project after that, where you start to really realize, oh, now I know how to handle something like this, or I've been in this situation before. And so that kind of learning It doesn't necessarily show up right at the end of the semester. It does for a lot of students. And I think Lauren was one of the students for whom it did show up. But there are a lot of students who gradually realize the value of the experience. So you have to be okay with that.
Which makes me really think that, again, in a place like MIT, what Terrascope is doing is highlighting certain emotional factors in learning, right? Because it's putting you in a situation where instead of there being a right answer and where you know that there's somebody on the other side with the right answer, there are, to use the famous philosopher Donald Rumsfeld's claims, right? There are known unknowns and there are unknown unknowns. And maybe you're exposing them to the emotion of being in the unknown unknown to some extent.
I don't know that I'd use the word emotion.
Okay.
But definitely the idea is to engage the whole student and to engage the entire student's intellect, right? All the things that you can think about, all the ways that you want to work are important for the class. I hesitate to use the word emotion because it can come with a lot of connotations that are not really what we do. Certainly students become emotional. They become emotional in all their classes at MIT at one time or another, right? But we are putting them in a situation where they become aware of what they don't know. We don't tell them, hey, you don't know this, you don't know that, you don't know the other thing. They become aware of what they don't know, and then we help to provide them support in finding the answers to the questions that they themselves have developed.
And I'm wondering also about whether it's worth trying to unpack a little bit. There's this kind of underlying layer of learning about big problems, and there's the specific topic of sustainability and environmental work.
Right.
And do students view that all as a package together? Or if you think about the incoming students, are they already on board with doing the environmental work, or do some of them get transformed into that?
So that's a really interesting question, right? So why do students take Terrascope? Why do they join the program? Some do join the program because of the focus on sustainability, but a significant fraction, probably even more than half, join for other reasons. They join because they like the feel of the community. They join because they like the idea of being in charge of their own classes, of being able to take on a project. They join because they like the idea of learning how to take an enormous problem of any kind and break it down into little pieces and solve it, how to organize a team around a problem.
I mean, that's useful in almost everything, right?
Anything our students are going to go into, they need to do those things. They need to figure out how to work with a team. They need to know how to break down big problems. And a lot of students recognize that coming in. And I have to say, there are a lot of students who joined because they checked off a box. They had 1 million boxes to check off about where they want to live and what kind of advising they want to have. And they just said, that sounds nice, and I'll check off a box. Or they join, I think in Lauren's case, actually, I think it was her dad who saw the Terrascope brochure and said, you know what, this sounds like you. You should do this. And she said, okay. So,
that's what she said.
And sometimes we have students who'll join because their parents really push them to it, and it's the one thing they feel okay giving in on. Right. Okay, no, I'm going to choose my own dorm. I'm going to decide whether to do a sport. Okay, fine, I'll do this learning community, Mom. So all those things happen. And on the other side, coming out of Terrascope, our students go into every major at MIT in approximately the same percentages as the rest of the MIT community. So there's a little bit of a bump in civil and environmental engineering and a little bit of a bump in earth, atmospheric, planetary sciences. But in general, our students go into all majors. And we think that's really important. I'm delighted that somebody who's majoring in chemical engineering has had a chance to think about sustainability for a year in a really intense way. Or that someone who's going into physics or math or any of these things.
So in some ways, it's providing a sustainability layer. Just like you were saying, there's Calculus 101. Everybody's getting that math layer. Everybody's getting that maybe physics or biology foundation. But at least for the Terrascope students, it's almost as if this is a mindset they can take into anything else that they do.
They really can take it anywhere else. And it does, for a lot of them, it does sort of open their eyes to the sustainability aspects of wherever they wind up. So, and we hear that a lot, actually, that, it hadn't occurred to me to think about this from a point of view of sustainability, and now I am.
Yeah, I'd love to hear a story or two of somebody who's, you can see the results of their Terrascope experience in their later life work. What have you seen of that?
I'm thinking of students who came in thinking, I want to just build robots. I really want to build robots. It's a cool thing to do. I'm going to MIT so I can learn how to build robots, right? And then coming out of the class thinking, okay, from a mechanical engineering point of view, I could build robots, but I could also, build a bicycle-powered corn husking machine, right? I could build a smart drip irrigation system, and where I can take these skills that I have that I thought I wanted to go one way with, and there are these other ways that I can take these same skills. They become aware of, it's not like converting to a religion, right? It's that they become aware that there are these kinds of problems that are important, that the skills they have and the skills they're developing can help address. Does that make sense? Is that a fair answer?
Yeah, I would imagine a lot of high school students, they're very deeply connected to the issues that they're aware of, but this is an opportunity to be exposed to a global scale expansion of the nature of problems that you can get engaged in.
What's a Terrascope problem like?
So to create a typical Terrascope problem, every Terrascope problem has something to do with sustainability. It's always a real problem that has to be addressed that is not currently being addressed sufficiently. It has to be a problem that matters. It has to be a problem that science and technology alone will not solve. So you really need to consider all of the elements, the social and political and economic and ethical elements and more. Those all come into play. And it has to be a problem where there is no perfect solution, where there will always be trade-offs, and you have to make those choices. So sustainability problems are really ideal in that way because they always involve trade-offs. They always involve interactions between the scientific and technical side of things and the economic, the anthropological, the philosophical, the political side of things. It's always part of the picture. And simply the physical aspects of the problems are always pretty complicated. And they always bring together multiple disciplines. One of the things that we focus on a lot in Terrascope is not imposing disciplinary boundaries. That you're looking at the problem, you're not looking at, I'm just going to look at the fluid dynamics of the problem, or I'm just going to look at, the structural mechanics of the problem. No, you're really looking at the whole problem. And sustainability problems are excellent for that.
Could you run down maybe 3 other types of Terrascope problems? We talked about the Boston and Bangladesh run that you've had this year. What are a few others to help us understand?
One example is come up with a plan to provide adequate fresh water for Western North America for the next century. After Hurricane Katrina, the question was come up with, first of all, decide whether New Orleans should be rebuilt at all. And if so, come up with a plan for rebuilding that will make the city sustainable for at least the next century.
So that's a fantastic question. And I'm sure there were people who actually were asking that question in the real world.
Hundreds of professionals, right?
Yeah. Did you ever compare your students' answers to that world?
Well, yeah. In the spring, we always go on a field trip to a place that's relevant to the year's problem. So the New Orleans year, we went to New Orleans and we met with every member of the mayor's cabinet. So we met with Public Works, and we met with Parks and Recreation, and we met with Homeland Security, and we met with every cabinet level official in the city of New Orleans, and our students had serious discussions with them about their own proposals and about what was actually going on in the city. So that can be a very enriching thing, right? So this year, when we were talking about adaptations to climate change, one of the things that we did was the trip. Well, we didn't take a trip to MIT because we're already here. And we didn't take a trip to Bangladesh, partly because it's a long way to go, it's an expensive trip, but partly also because if we'd gone to some place that is sort of threatened by climate change, but where they haven't done a lot yet, what we would mostly see is what's threatened, what's potentially going to be destroyed. What we really wanted to do was to go someplace where we could see some pretty effective adaptations to the kinds of problems that might come with climate change. So we went to the Netherlands, right? And in the Netherlands, we got to see a variety of protections and adaptations, particularly to flooding and to saltwater intrusion, that have been built over the centuries, including some relatively older ones and some very recent ones, and you can really compare the different approaches, the different philosophies. And so the students could talk to hydraulic engineers and could talk to anthropologists and could talk to historians about how did these things come about and what approaches are you taking here? And then they come back here and can start really thinking about how is that applicable here and how is that applicable elsewhere, Bangladesh, elsewhere. And
So what happens in the spring?
In the spring, there are 2 classes and a field trip. So one class is called Design for Complex Environmental Issues, and it is fundamentally a design class. So we help the students go through the design process, learn the design process, but you have to design something. And so what they're doing, they've broken up into smaller teams, and they're designing things that might be part of the solution to the year's problem, right? So this year, when the problem had to do with adaptations to climate change, one of the teams built the beginnings of a heat detecting system that you could mount on a drone to go out and look for the beginnings of wildfires. Another group built a bus stop that would be more comfortable in extremely hot weather to help encourage people to continue using public transit even in the heat. Another group worked on a rainwater harvesting system for rural Colombia. Another group worked on a system to try and reduce, there are these enormous piles of garbage in places like the Philippines where the storms that are going to be intensified by climate change can make those really dangerous places. And so they built a physical device to help empower the garbage pickers who are there, to help empower them, to help them achieve a certain amount of financial independence, and also to make their work more efficient. A bicycle-powered plastic shredder. And then a group worked on a system for harvesting water out of fog. This is based on an earlier piece of research done here at MIT. So that's an example. That's one of the spring classes. The other spring class is called Terrascope Radio, where the students create a radio program about the year's topic. And so that is a very different way of thinking about things. They now have a non-technical audience. How do you engage people who are not like yourselves in the stories that make this topic really important and interesting? And then, of course, there's the field trip.
This year's field trip was to the Netherlands.
This year's field trip was to the Netherlands. Yeah.
Terrascope is fantastic, but it's at MIT. And, MIT is also fantastic.
It's at MIT.
Well, okay. MIT is also fantastic, but it's a very wealthy, powerful institution in the first world. So is there a way that this style of problem solving can happen in places with fewer resources?
It really can. One of the really great things about this particular educational approach is you don't need an MIT to do it, right? It's terrific to do it here. It's terrific to do it with our students. But the fact is that students everywhere have the potential to do this kind of problem solving, engaging their entire humanity, engaging their entire intellect in problem solving. So one of the things we are trying to do is to try and spread the word a little bit. And so this year, for example, at the University of Chile, a program began based on the way Terrascope works. So a professor from University of Chile came and visited us for a year, saw the kinds of things that we do, decided what aspects of what we do are applicable to her own students and her own institution, and she's developing her own problem. But you can do this. You could do this at a high school. You could do it in an elementary school. It takes a certain level of commitment, but if you have the faculty and the administration who are committed to doing it, it really can be done. It's a different flavor everywhere you go, but the idea that the students are in charge of their own learning and that they have ownership and that ownership gives them motivation to really go deep and to really get at the heart of the problem. One of the things about Terrascope is every Terrascope class has a high stakes presentation of some sort at the end. And by the end of the class, the students realize that they don't really care what we think of their work. They really care what the audience thinks of their work, what the public thinks of their work. And that changes our relationship with them. We then become the coaches who are helping them to do their best in this public setting rather than their evaluators. And that style of education works with anybody. I would argue that it probably works even better with people who are not typical MIT students, with people for whom traditional sort of lecture style learning and textbook style problem solving has left them a little flat. MIT students are all good at those things. But imagine you're somebody where those things are not your strength, but think about a problem that you have full ownership of. Can be a very empowering experience for any student, anywhere.
Yeah, I'm wondering about the opportunities to do this outside of institutions of learning.
Right.
That people in the community.
So could this be a form of citizen-driven learning as opposed to formal institutional learning?
So a significant part of my background is actually in what's sometimes called free choice learning, what's sometimes called informal education. It's the kind of learning that happens in museums or media or clubs. What characterizes it is that the learning is driven by the learner's own needs and interests and desires, right? So a large part of my educational approach comes from my background in free choice learning. The reason I don't call it informal education is because that assumes that you can't do it in a formal educational setting.
Right.
And a large part of what I want to do is to show that you can do free choice learning in a formal educational setting. So what you're really saying is, can you do this as free choice learning outside a formal educational setting? And I think you really can. I think in order to do it, you need to figure out who's your audience, who are your students, and what are their goals, who could be the audience for their presentation or whatever their final product is. And you really need to shape it around them. So I can't give you a syllabus now, right? For that, I can't give you a description of how I would do it because it depends so deeply on the nature of the people you're doing it with. But it's unquestionably the case that you could do this entirely outside a formal academic setting.
What do you think, Rajesh?
Exactly. This was fantastic.
We hope you've enjoyed this extended interview cut. Please be sure to check it out in context in episode 2 on free choice learning in universities. The Climate Conversations podcast is engineered and edited by Dave Lashansky. Project and media support is by my MIT Open Learning colleagues Laura Howells and Michaela Joyce. Please subscribe and rate us wherever you find your podcasts. Join the community on climate.mit.edu and be in touch at Twitter, climatex_MIT, and Facebook, group named MIT Climate. For my co-hosts Rajesh Kasturirangan and Dave Damlur, I'm Kurt Newton. Thanks so much for listening.